traditional businesses by banks and telcos and retailers and so on, who before were really just looking at the technology, but now you're seeing the business getting involved in proof of concept and actual implementation. So if you look at Geoffrey Moore's Crossing the Chasm framework for new technology adoptions, what you see is we're moving from the early innovators to the early mainstream. So we're crossing the chasm, and that's very positive. And over the last year, this big data part of our business has been our fastest growing part of the business. So it's been very, very positive. And have problems is typically when you have very IT-driven initiatives. So the technologists get very excited about the new technology, but they don't engage the business, and they don't have real business case, and they play with the technology, but they don't actually create any value from the technology. And the other thing is that the big data open source world was designed by computer scientists for computer scientists. So if you don't have an exploration discovery platform in addition to the technology, which is the file system, then you will not be successful. So that's a very easy chasm to fall into. You do the technology part to store all the data very cheap, but you don't do the discovery part to create the value. Framework called the Unified Data Architecture. So in the Unified Data Architecture, where there are really three main components. There's the data lake, which is made up of the Hadoop open source technology, where we can store all data forever at the lowest cost per terabyte. So it means you don't lose any data. It doesn't matter what data, what form the data comes into. We can store that data, and we can keep it at a very low cost. Then we have an integration of the discovery platform with the Hadoop platform. So the discovery platform is based on technology that we acquired from a spin-off from Stanford University. And this discovery platform allows advanced analytics beyond just simple SQL processing. So you can do MapReduce processing, you can do graph processing, you can do text processing, and that discovery platform has a direct access to the Hadoop distributed file system. And so we built something called SQL-H, SQL for Hadoop, that allows a non-technical user to access the Hadoop distributed file system. So this is a very important part of Teradata for Hadoop. And we use an open source technology called hCatalog to provide the metadata to allow that to happen. And then last piece is the Teradata Relational Database, which is where you manufacture the value. So I think of discovery platform as data R&D, data research and development. And then the integrated data warehouse is where you manufacture the value. Many users, many concurrent queries, very high production requirements. That's the core Teradata technology in the integrated data warehouse. So all three of these components, they all integrate together. So this SQL-H, I can execute from Teradata to Hadoop or from the Astrodata to Hadoop, all based on the open source technology. In other industries, even across geographies. Korea is very strong in manufacturing. We've got some of the biggest, most important manufacturing companies in the world, like Samsung and Hyundai and so on. And these companies are quite aggressive in thinking about how to use big data technologies. One of the main factors that influences sophistication in big data technology is how competitive is the business environment that you're in. These environments, if you're more competitive, then of course you have to be more innovative and you have to be more aggressive about adopting big data technologies. And in manufacturing, sensor technology provides a very rich source of big data analytics. So the manufacturing companies in Korea, I think, recognize this and are aggressively pursuing big data in that sense. Probably even more aggressively than the banks and the telcos and so on, which are also, of course, in Korea, relatively sophisticated, but the manufacturing companies are more aggressive. Predicting the trend and looking at the early adopters, now I think it's becoming a more mainstream thing. Right? So it's this difference between the left side of the chasm and the right side of the chasm. You had the very early adopters, you had people thinking about how to do this, and we had some customers using the sensor technology, but it was the very leading edge people. Now I think it's getting into a more mainstream adoption. It's probably early mainstream. I wouldn't say it's full mainstream, but early mainstream. But it's definitely more people thinking about it, and not just the bleeding edge innovators. One of the industries which has the most potential, but quite frankly is very behind, is healthcare industry.
Healthcare.
Yeah, there's a huge potential in the healthcare industry, but this industry is notoriously very conservative, of course, because healthcare is something that is very high risk if you do it wrong. So they are very cautious and have not really used big data in a very effective way, but the potential is huge. And so I think this is one area that has a lot of opportunity in the future that is really not being exploited right now. The power and utilities business is another area where sensor technology can make a huge difference, but it's still in pretty early stages. We have some implementations at interesting places like Southern, but there will be much more adoption in the mainstream in the years to come. Actually, you can listen to after my speech and hear from Royal Bank of Canada, so I'm not going to talk about them because they can talk about themselves. One I will mention is T-Mobile, which is a large telecommunications company in the US. They had a data warehouse for quite a while, but then what they did was introduce analysis of call center interactions, analyzing the text captured by the call center reps to describe the call that was taking place. And they were able to use the text description of what was going on in the call center interaction to detect which customers were most likely to defect, or where there were opportunities to do cross-selling and upselling and those kinds of things. And so they took this, this data, and they were able to see patterns that before they couldn't see, because in the past, the text they just threw away. They didn't really know how to use the text in a very meaningful way. I mean, they didn't really throw it away, but they didn't use it analytically. They used it just for archiving and so on. And so now that they're using that analytically, they've been able to target people that are more likely to churn and keep them as customers. And they started this text analytics on the Astrodata platform. And then as it grew bigger and bigger, they say, this data is getting quite large, we need to change the economics. And then they went to deploy the Hadoop distributed file system. So they first had the integrated data warehouse that had the data about their customers and calling behavior and the normal stuff. And then they expanded with the Astrodata platform to do the text analytics. And then they expanded to Hadoop to sort of change the economics of the whole environment, to be able to store all data forever at that very low cost. And exploitation requires a level of scale that is probably not appropriate at this time because it's still early in the marketplace for small businesses. Medium-sized businesses, yeah, maybe if they're relatively sophisticated in IT and so on. But big data is largely for pretty significant sized organizations. But if you're very technically advanced, like for example, Netflix delivers online video content and so on. I wouldn't say they're a huge monster company like T-Mobile or Walmart or something like that, but they're very technically sophisticated, and they've used cloud technology to initiate their data warehousing and big data capabilities, and they've been very successful, but they're also very sophisticated. Technically. Silicon Valley company, lots of very hardcore engineers. We provide all the pieces, we integrate all the pieces, and we focus on delivering business value much more quickly than product-oriented companies. Product-oriented companies, they want to sell you this product or that product and so on. We're really selling a solution together with industry expertise to help people exploit the value. So for Teradata, it's not about the technology and the product as much as it is about a solution which includes the industry expertise to extract the value. I think that one of our core differentiators is it's about delivering business value. It's not just about dropping off a technology and say, okay, go plug it in and have fun with it. So very, very much focused on business value creation and having all those pieces of the unified data architecture integrated together. Nobody else has all the pieces. Nobody else delivers the value as quickly as Teradata. Types of data. I think it was perhaps important to get people's attention. So it was good from that point of view. But in the future, I believe that we will not use the term big data anymore. I think it will just be data. And I think that the non-traditional data types that we now call big data, they will be integrated in with the traditional data types, and the value creation will take advantage of whatever data makes sense. Yeah. Big data, small data, square data, triangular data, it doesn't matter. We will integrate them together. Now we may use different technologies for different types of data. That's part of the logical data warehouse construct that Gartner has defined, and that's what the unified data architecture does. But I think this concept of big data as a separate concept will go away. These markets of integrated data warehousing and big data will just merge together. Well, it sounds to me like they're confused, quite frankly, because huge value has been created in CRM. Anybody that thinks CRM didn't create value didn't do a good job in their own company, because CRM has created huge, huge value. And I think that big data also will create huge value. Now, when I say CRM, I want to be very careful. Analytic CRM, right? So I think that some of these operational CRM implementations, people spent a lot of money and they didn't change their business processes, and they didn't get full value, right? But on the analytic CRM side, if you implement it properly, test and control groups and target marketing and so on, I think it would be impossible to say that that was not successful in any company that executed well. And that's the same with big data. I think that if you do not do the big data thing, you're probably analyzing customer transactions for which you can understand their value, but you don't understand customer interactions, which means you don't understand their behavior. If you want to understand customer behavior, you really need to analyze the interactions below the level of transactions. And that's really what big data is about in the end. And the interactions, of course, come in non-relational forms like clickstream data and social media interactions and voice interactions. These are all non-traditional data, but really the key point is it gives you visibility to customer behavior. And that's fundamentally different than the transactional activities of a customer. So there's huge value there. People just have to get the right models to extract that value and translate it to action. Well, I was making an analogy to your CRM, but for example, in manufacturing, if you look at probably the two most important manufacturing companies in Korea are arguably, if you're an automobile manufacturer like Hyundai, I want to know how the driver is interacting with the car. I want to capture every interaction with the vehicle so that I can design better vehicles. I can drive safer vehicles, easier to drive vehicles, more efficient vehicles if I understand all the interactions. So sensor data, to understand what I'm doing with the vehicle, that's interactions, it's very, very valuable. If I look at Samsung, probably another very important manufacturer, right? I want to know exactly how you're using your Galaxy device so I can design a better device, so I can add more features. The interactions are very important. The transaction is you bought the device. Okay, that's good. I know that you bought a device. But imagine that if I collect all the data of how you use the device, how much better my engineering will be. So I believe that the big data for these manufacturing companies is hugely, hugely important. Hugely important. So as we take that data and we capture it in all aspects of banking and telecommunications and retailing and automobile manufacturing and so on, we have huge opportunity. Now historically, this opportunity has been captured in business intelligence. Business intelligence meaning that we gather the data into an environment where decision makers within our companies can make better decisions on behalf of our company across a number of different industries. Industries like financial services, this is one of the first early adopters of this concept. Retailers, many different organizations, automobile manufacturers. The example that I'm going to use in just a moment is in the power and utilities business. Power and utilities we think of as a very boring, not very innovative business in most organizations, because they're basically a monopoly. There's not a lot of competition for power and electricity in most countries and most marketplaces. But even in this environment, you're seeing them think about how to use data and convert it to products, services for consumers. So this example comes from Southern California Edison. They've been doing this for a little while now. And this is a California... We beg of you. And this begging works reasonably well for certain people. Right? They use another technique. Guilt. They make you feel guilty if you're using the power to do your laundry in the middle of the day. In Southern California Edison, it's very popular to have this green movement. Green means you're very ecologically sensitive and so on. So they have television ads. You are not green if you're doing your laundry in the middle of the day. You are a bad person. Because if you're not green, you're definitely a bad person. And in Southern California, this works very well. People feel very guilty about not being green. Right? Works on a lot of people, but not everybody. There's another kind of green that works even better. It's money. If I price the energy differently during the middle of the day than the middle of the night or the weekend, then people will change their consumption patterns. So it's very interesting. So before they couldn't do this because before you only got a bill at the end of the month. How much power did I consume for the month? Wells Fargo Bank and Discover Card and Lloyds Banking Group, they started providing information to their retail consumer banking customers to do analysis on their spending patterns and saving patterns and so on. The open data revolution creates some other interesting effects. This one I'm putting up here is called Linus's Law. It's named after Linus Torvalds, who's the father of the Linux operating system. So he created this sort of open source revolution in Unix to create an open Unix to replace all of these proprietary versions of Unix that have been created by these hardware vendors for this open data initiative. And when we look at this open data philosophy, right, it creates some opportunities for crowdsourcing analytic insights. So Herman put up a slide earlier about Netflix. So Netflix, they provide a service to deliver online content like House of Cards, but you can watch television shows, movies, documentaries, many different things. And Netflix is very interested in understanding what are the topics that you would like to festival. And it's called Lollapalooza. Right? I don't know how many of you might have heard of it. I suspect that some of your children might have heard of it. Right? So this is Nick Cave. Nick Cave is kind of an alternative performer, and the people that come to this Lollapalooza, they are kind of strange. There's a lot of piercings on the ears and the nose and the tongues, and a lot of tattoos and a lot of black leather. Sort of a very different audience than is in this room. Right? So why am I talking about Lollapalooza at a data conference? Well, there's another festival that takes place in the US. It's not called Lollapalooza. This is in the US also. But the festival I want to talk about, it's called Datapalooza. And this is targeted for equally strange people. But these kind of strange people, they have very high pants with white socks. And they have little plastic pocket protectors, and they have, you know, these lots of electronic devices, and these are the geeks, the data geeks. Right? And so this Datapalooza, this was initiated by Todd Park. So Todd Park, he is currently the Chief Technology Officer for the United States. He is Barack Obama's Chief Technology Officer. But at the time when he started this, he was the CTO for the Department of Health and Human Services, which
I would argue, is one of the most important areas of data analytics worldwide, healthcare data. And so he wanted to instigate innovation using open data about healthcare. So he took this healthcare data. Of course, he anonymized it because healthcare data is very sensitive, so you shouldn't have it, publicly known who's getting what treatments and so on. Anonymized it and made it available. And then he said, all the data geeks, come to Washington, D.C. We're going to have a contest, and we're going to give out money to people who can create innovation on top of this data. Over 1,600 data geeks showed up. They had to close the doors. There were too many. They had to say, sorry, no more room. And they then had a contest to see who could create the best data products from this healthcare data. And a lot of interesting things got created. Now, believe me, there were a lot of bad ideas too. It's just like if you've watched this show, I don't know if you have Korean Idol. We have something called American Idol, where people come and they sing, and a lot of them are very bad. But every once in a while you get a good one, right? It's the same thing with these ideas. If you get enough smart people, eventually there are going to be some good ideas that come. So one of them is an application called iTriage. So iTriage is an application that runs on your smartphone. You type in English language, what are the symptoms that you're feeling? I'm feeling a high temperature, my bones are aching, whatever it is. And iTriage will tell you which hospital should you go for treatment. Now this is pretty interesting because that's a hard decision to make, right? So if it's something very urgent, like the symptoms say that you just had a heart attack, or that you're about to have a heart attack, you should really go to the closest hospital. The distance to the hospital is the most important thing. But if it's something that's less urgent but maybe very serious, then it's important to go to a hospital that has the most experience in treating this particular thing. Maybe it's cancer, for example. You don't want to go to the nearest hospital to treat cancer. You want to go to the hospital that has the most experience treating the cancer that you have. And maybe in some cases you might want to drive even a little bit further to get the lowest cost.